today we're going to talk about scientific investigations. Scientific investigations are usually performed to solve a problem or answer a question. The scientific method, which I'm sure you've heard of before, is a process that provides a logical approach to problem solving. Although there is not a procedure that all scientists must follow when performing scientific investigations, most include the following steps. First, they identify a testable question. Only testable questions can be answered through scientific investigations. Does fertilizer make daisies grow taller? Is an example of a good testable question. However, questions about opinions, emotions, or supernatural events do not make good testable questions for scientific experiments, even though some information may be gathered about opinions by performing a survey. Testable questions may come about as a result of research, observations, or even data gathered from another investigation. Next, we research the topic. Before proceeding with an investigation, it's often useful to perform some basic research on the topic that's to be studied. Research may include making observations or gaining information from reliable sources. Reliable sources of information should include scientific evidence or data that has been interpreted by individuals who are knowledgeable about the topic of investigation. Experts, scientific journals, and textbooks are examples of reliable sources of information. Newspaper editorials and interviews with non-experts are obviously not reliable sources of information because they're often based on opinions rather than facts. The internet should also be used with caution because it is not always clear if the author of an article or website is an expert in a particular field. Next, we form a hypothesis. All a hypothesis is an educated guess or a statement that proposes a possible explanation to some phenomenon or event. Hypotheses are based on observations or other information gathered through research. A hypothesis should have the following traits. A hypothesis is written as a statement. Since a hypothesis is meant to be a possible explanation, it should not be written as a question. So, why do some objects fall faster than others is not a good hypothesis. But objects fall at different speeds due to their shapes is an example of a good hypothesis. Next, we want to make sure that hypothesis is clear. Vague terms should not be used when forming a hypothesis. Instead, these terms should be clearly defined. For example, the statement, "Sometimes there is morning dew on the grass," is not a clear hypothesis, but when the temperature drops below 50 degrees Fahrenheit at night, the grass will have dew in the morning is a clear hypothesis because it details the exact conditions under which the dew is expected to appear. A hypothesis should also be testable. It must be possible to carry out a scientific investigation and gather evidence that will either support or disprove the hypothesis. Dogs are happier than cats is not a testable hypothesis because it's not possible to clearly define happy, nor is it possible to design an experiment to test this hypothesis. Next, leading into design an experiment to test the hypothesis. So once a testable question and hypothesis are identified, an experiment must be designed to test that hypothesis. All factors that can change in an experiment are called variables because they can vary. The independent or manipulated variable is the factor that's manipulated or changed by the person performing the experiment. The dependent or responding variable, that's the factor that changes in response to the manipulated variable. A fair test is an experiment or comparison in which only one variable is changed or tested. Hypotheses can be used to identify the variables that will be investigated. For example, if the hypothesis states, if salt is added to water, then the freezing point of the water will be lowered, the independent variable is the amount of salt that is added to the water, and the dependent variable is the freezing point of the water. Make sense? I always had a hard time understanding that when I was in school, so I want to be sure that you understand the difference between the independent variable and the dependent variable. Next, we collect data. Scientific investigations produce data or evidence. Data is just information, and it includes observations and measurements that are made during experiments. Observations involve the senses of sight, hearing, touch, and smell. In most cases, scientists use special tools like microscopes to increase the power of their senses or make their observations more precise. Data can be recorded by writing or drawing in a scientific notebook or journal. Data can also be recorded by using computers, cameras, videotapes, and other tools. Recording data in tables can also help keep observations neatly organized. Next, we interpret the data. When an experiment is finished, the data from the experiment has to be analyzed. Organizing the data in tables and charts and graphs makes it much easier to see patterns or relationships between one variable and the other. Next, we explain the results. After gathering and interpreting the data, conclusions have to be made about what happened when the manipulated or independent variable was changed. Then, we compare the results to the hypothesis. The results of the experiment should be compared to the hypothesis or prediction. Do the results support the hypothesis or prediction, or do they differ from what was expected? Hypotheses and predictions should not be thought of as right or wrong. Something is usually learned from the experiment, even if the results are not what was expected. If the results agree with the prediction or hypothesis, it is said that the results support the hypothesis, or that the hypothesis is retained. Fancy word. When the results do not agree with the initial prediction, it's said that the hypothesis was rejected or not supported. It usually takes more than just one experiment to completely disprove a hypothesis, though. Hypotheses which are studied in depth and are consistently supported may, over time, become something called a theory. Finally, we communicate the findings. The results, analysis, and agreement or disagreement of the findings with the hypothesis or prediction should be communicated to others. Communicating results helps people learn from one another. Communication is also essential to maintaining an investigator's credibility when other scientists and society